Okay, and then the last problem out of 9.1. This is where they kind of throw the special cases at you with some different things here, where you'll see some different ways when the graph lines up. So let's start with an order. Let's start with 4y plus 3 greater than or equal to 27, or 2y minus 3 is greater than or equal to negative 1. Okay, with the OR, again, it's two separate equations. Let's do it two separate times and see what you get for the answers here. Okay, so for this one, we'll subtract 3 from both sides. Leave us with 4y greater than or equal to 24. Everything's positive. We don't have to change any signs here. Divide both sides by 4. We've got y greater than or equal to 6. On the right-hand side, we're going to add 3 to both sides. So we've got 2y greater than or equal to 2. Divide both sides by 2. Now we've got y is greater than or equal to 1. They get no negatives, so we don't have to worry about swapping any signs. Okay, when you graph these, there's our number line. We're going to start at 6 for this graph. That one has the bar underneath it, so that's going to make it a solid circle, or again, if we go ahead and do it in interval notation, that's going to make a square bracket. So there's our square bracket. That one's headed off to the right-hand side. For the 1, we're going to start back here, also a square bracket. This one's also greater, so it heads off in that direction. Now, and the big thing is with the OR, it says anything that we're covered, that's the answer we're looking for. But in this case, the 1, we started with the 6 here. The 1 went back and covered him up, right? So in that part, the 6 is just kind of engulfed in the 1, that it covers on top of it. So the final answer on this one would be that the answer would be 1 to infinity. Because the 1 went ahead and covered up the 6, and since it's anything that's out there, well, the 1 does the same job as the 6, so we'll just go ahead and use the 1 there. So if they're going in the same direction in the OR statement, just pick the one that covers more area. That's really what it comes down to. And for the OR statements, that's kind of the trick question, that you only have half an OR, because both of the paddles are on the same side. Which, if you're going to paddle that way, you're just going to go in circles for a while. Okay, and then the other one that they'll give to you is an AND statement. Let's go with 4x minus 4 greater than or equal to negative 8. And they'll actually use the AND part of this one, because most of the time it'll be two separate. To get a trick question with the AND statements, you almost have to have two separate inequalities the way it's written. Not necessarily, but most of the time you have to have two separate ones. So go 4x minus 4 greater than or equal to negative 8, and 2x plus 5 is less than or equal to negative 3. And again, with the AND, that really means it's the overlap. You're looking for the intersection of those two things. Okay, for this one, we're going to add 4. So 4x would be greater than or equal to negative 4. And then we're going to divide by 4. Now, when you divide by 4, this negative doesn't do anything, because you're not doing the part you're going to do to both sides is you're going to divide both sides by 4. And since it's a positive number, you don't change the inequality sign. Just leave it like it is. So it's going to be x greater than or equal to negative 1. If the negative had been on this 4 that was with the x, that's when you would change that sign. But since you're dividing both sides by positive 4, you don't have to worry about changing anything. Track 5 is less than or equal to negative 8. Divide both sides by 2. So we've got x is less than or equal to negative 4. Now, again, if you can think about it in your head, go ahead and do that. But most of the time, it helps to actually put those on a graph just to see what that graph looks like. Again, for the end, that means we're looking for the intersection. We're trying to see what they have in common. So with the green part, we're going to start at negative 1. That one is a square bracket, and it's going to the... Oop, not that way. Wrong way. Goes to the right, so it's going this way. The blue graph, that one is less, so we're going to start at negative 4 and goes that way. So if it's the intersection, where the two graphs cross? They don't, right? So for that part of it, same thing for that one. There is no intersection, so that would be what they would call the empty set.